So when we look here, we see that the cosine function does in fact have an odd power. So we are going to pull one cosine off and convert the leftovers. So let's do this slowly and carefully. So I have pulled one off right there. So this is one cosine has been pulled off. These cosines are left over. Those have to be converted into sines. So let's go ahead and use the Pythagorean theorem. We will write cosine squared as 1 minus sine squared. And our goal here is to let u be the function that has what we pulled off as its derivative. So we want to let u be sine of x precisely because its derivative matches right there. So if we let u be sine of x, we can pull that 4 all the way out to the front. We'll have a u to the negative 3/2, 1 minus u squared du. And then we're going to distribute the u to the negative 3/2, so we'll have u to the negative 3/2 minus u to the 1/2. And now we're in a position where we can do integration with the power rule. So we will have 4 times, we add 1 to the exponent and divide by the new exponent. So we add 2 over 2, we'll get u to the negative 1/2 divided by negative 1/2 minus u to the 3/2 divided by 3/2 plus c. Let's clean this up a little bit. So we're going to have 4 multiplied by, dividing by negative 1/2 means multiplying by negative 2. The negative 1/2 power in the numerator is a positive 1/2 in the denominator, and that's a square root. So let's do our back substitution. We know that u is equal to sine of x from up above. And so we're going to take that, any place we see a u, we'll replace it with sine of x. So in here, we're going to have sine of x. And then minus, dividing by 3/2 is the same as multiplying by 2/3. And we're going to have u to the 3/2. Well, u is sine of x. So we'll have sine of x to the 3/2. And then plus c. In the final step, there's no point in having this 4 factored out of just part of the answer, right? It's only distributed to these 2 terms. It has nothing to do with the c. So it's generally better not to have it factored out. If you have a constant factored out, you want it factored out of everything. And so usually we would not factor just part of the answer. And we would write our final answer like that. Boom.